Hello friends, welcome to my YouTube channel. I'm Malav Doshi and today we will learn about conservation of momentum. So let's first understand what is the term conservation. Conservation means conserving or neither adding anything or not subtracting or taking out anything from the particular quantity. For example, if we take conservation of mass, it states that the mass of reactants or mass of the elements or the compounds which are reacting before the reaction would be equal to mass of that things after the reaction also, but it does not apply in nuclear reactions. We will look at it on later on. So first we have to see this conservation of momentum. Conservation of momentum states that if any two bodies are there, their initial momentum would be equal to their final momentum. Means if we consider that two bodies as a whole system, then their initial momentum would be equal to their final momentum. For proving this, let's do an experiment. Let's assume a ball going with mass m1 and initial velocity u1. So we have m1 as mass and initial velocity as u1 for ball A, and it collides with another ball of mass m2, and that mass m2 ball was going with initial velocity u2, and they both collides for time t. Suppose ball 1 exerts force F12 on ball 2 and ball 2 exerts force F21 on ball 1. So we will see what is it, and obviously if M1 is colliding to M2, then U1 would be greater than U2. And if we visualize it as diagram, then it will be like this, that M1 is going with velocity U1, M2 is here, it is also going with velocity U2. They both gets collide for time t, and after collision, M1 attains a final velocity v1. They did not stop because u1 was greater than u2. Okay, so M1 attains final velocity v1 and M2 attains final velocity v2. Just see. So if we see force 12 F12, that it was ball 1 exerts F12 on ball 2, it would be m1 into v1 minus u1 divided by 2. As we know that from second law of motion, that force is equal to mass into acceleration. If you want that derivation, then click on just that I icon or go in description. You will find the derivation that y f is equal to kma, and yv does not include k here. So if f is equal to ma, then we know that a is equal to v minus u by t, then f is equal to m into v1 minus u1 upon t. Okay, so ball 1 exerts force m1 v1 minus u1 upon t, or m1 into acceleration. F21 exerts m2 into v2 minus u2 on by t on ball 1. Okay, so but from third law of motion we know that every action has an equivalent opposite reaction. So if ball 1 is exerting force on ball 2, that would be equal to the force of ball 2 exerting on ball 1, but in opposite direction. Okay, if this both are direction, so we can write like that from third law of motion, F12 is equal to negative F21. I told you, because if M1 exerts force M2 on M2, then M2 will also exert same force on M1, but in opposite direction. Therefore here we will include negative. So M1 V1 M1 U1 M1 V1 minus M1 U1 is equal to minus M2 V2 plus M2 U2. Okay, so we will have M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. So if we write like that, that initial momentum of first ball plus initial momentum of second ball would be equal to the final momentum of first ball and final momentum of second ball. I told you that if we consider this both as a whole system, we have to just prove that their initial momentum is equal to the final momentum. Conservation of moment is just the same thing, that they do not lose any momentum while going on the process. Hope you like this video, and if you still have any queries, then let me know in comment section. And if you like this, then subscribe my channel and press the bell icon to stay tuned. Thank you.